He did postdoc in information technology from UniKL, Malaysia. He is currently serving as professor and HoD at Karachi Institute of Economics and Technology in Pakistan. He has more than 100 research publications with a citation count of 1200 and H index of 11. His research area is related to the mobile networks. And he's also a founding member of Presidential Initiative of AI and Computing in Pakistan with more than 10,000 enrolled students at present. So his topic of webinar today is 6G, an overview and a novel context-aware caching scheme. So we welcome Dr. Noman here at KFUPM for this, and it's our pleasure to have him here for this webinar and very emerging topic that we going to discuss today. So we will continue with the webinar now. He's going to present for about 30 to 40 minutes. We continue the presentation on this topic. And attendees can raise their questions on the Q&A section. And I will basically look after those questions, and we will take questions after the presentation at the end. We were 20 minutes before the end of the webinar. Okay, so let's begin. So Dr. Noman, the floor is yours. You can continue now.
Thank you very much for brief introduction of me. Bismillahirrahmanirrahim. So today I'm going to talk about 6G networks, a brief introduction, and then I will talk about the emerging technologies that have enabled the 6G network, and finally just a schematic approach for the context-aware caching scheme for mobile networks. So we know that mobile communication has progressed over the years in such a way that after every 10 years, there is a new generation. So starting from 1980s, we have the first generation, then the second generation enabled by GSM, then we have the third generation of mobile communication in which there were standards like UMTS, then for the fourth generation where we have LTE, then the fifth generation that is currently under development, and then continuing this pattern, we can say that by 2030 there will be a next generation of mobile communication. So people have started working on it, and so why do we need the sixth generation? According to Cisco, there will be around 14.7 billion devices by 2023 that will be connected over the internet in the form of Internet of Things. Similarly, the popularity of multimedia contents is also exploding. People are trying to use the mobile networks, the cellular networks for browsing multimedia content, the social networks. So supporting such a voluminous data is not possible by the 5G networks. So let me summarize first the earlier generations, and then I will talk about the need for the 6G network. Why do we need 6G network? So we started with the first generation in which we have AMPS, Advanced Mobile Phone System, and other standards like TEX, eTEX. Then in 1990s, we have GSM, IS-95, CDMA1, and other standards. Then 3G have other standards, 4G, 5G. So the current standard is called 5G NR, the 5G new radio. The data rate has tremendously increased in the past few years, starting from the data rate in kbps to mbps, gigabits per second, and then we are expecting in 6G that we will have the data rate of around terabits per second. Uh, Multiplexing technology, the multiple access technologies uh, like FDMA, TDMA, and CDMA have evolved, and in 5G and 6G, we are anticipating more advanced multiple access techniques. So, in the earlier generation, uh, in the first generation, we were expecting the voice service, then SMS was introduced, and then similarly, uh, multimedia contents are now being used over the cellular network. Then switching technology, earlier we were using circuit switching, and then we have packet switch networks. And so similarly, the handoff mechanism, earlier we have horizontal handoff, now we have vertical handoff. So following this trend, we are anticipating that the 6G will emerge that will provide ubiquitous connectivity in which everything around us will be connected. We will be provided seamless connectivity. Even we are not aware that we are using a computing device, we will be connected seamlessly via different interfaces like voice. We will be interacting with computing devices. We will be sending a command that will be relaying over the network. So this is the future that I'm going to talk about further, and it will provide intelligent network orchestration and management. What is intelligent network orchestration and management? Let me tell you one thing, that AI is going to play a very important role in 6G networks. So the AI-based sensing mechanism will be used to collect the data, and based on the data that is collected, different types of intelligent decisions will be performed in terms of improving the architecture, the protocols and operations, the configuration, policies, automation. All of these things will be based on artificial intelligence. There will not be any human involvement. The complete network management will be performed based on the data collected, based on the statistics that is collected. Even the spectrum decisions will be based on artificial intelligence. So, in the 6G networks, to be starting from first generation to 6G networks. In the 6G networks, we will have novel spectrums. Uh, for example, we will be using terahertz spectrum for communication that will provide very high speed. Then visible light may be used for communication. Some research papers have also used the concept of cell-less network. There will not be any cellular network. In fact, it will be cell-less network. Then disaggregation and virtualization. Even the lower layers of the protocol stack, such as MAC and the physical layer, all of the layers will be virtualized. We will talk about energy efficiency, artificial intelligence in the sixth generation network. So just a little background about 5G. I have already told a bit about it. 5G is about high frequency network function virtualization. All the network function is virtualized by use of containers and virtual machines. Software defined networking is used. The whole network architecture is based on software, and we have the concept of network slicing, different slices for different groups of users, massive MIMO, multiple input, multiple output MIMO based antennas, in which we have multiple array antennas, and they will be using a spatial access technology to simultaneously transmit uh, the data using different antenna elements. The data will be simultaneously transmitted. So all of these concepts were used in 5G network, and there were different applications such as IoT is the predominant application of the 5G. Then smart city, industry of things, industry 4.0, e-health, wearable computing, smart utilities. These were some of the applications. Uh, Now, there were three use cases proposed by the uh, 3GPP, Third Generation Partnership Project. They proposed that three types of services: enhanced mobile broadband services, in which we have a huge capacity for streaming multimedia contents. Then URLLC, ultra reliable low latency communication. This is another type of application in which we need a zero latency real time communication, and the possible applications may include remote surgery, and then massive machine to machine communication, in which machines will be communicating with each other and to realize a true internet of things. So these were three use cases of uh, 5G that was proposed by 3GPP project. Uh, However, uh, the 5G is not going to meet the connection density requirement. If you see the first use case, it requires 1,000 times capacity in a per kilometer square. So a large number of devices will be available in a small location, and to support such massive number of devices we need some other mechanism that is not possible by 5G. So there will be a large number of concurrent connections, a large number of devices to be connected at the same time. Then new paradigms for extended reality, in which the true feel, the true uh, connectivity is felt, the augmented reality and the virtual reality is extended further. We are also seeing the emergence of Meta. So extended reality is on the way. We need to address this paradigm. We need to provide the support for this paradigm in the next generation mobile communication system. Then the concept of flying cars, mind machine interfaces, telemedicine, the use of novel terminologies in medical science, such as remote surgery. So, all of this is not possible in 5G network. Then, in the 6G network, there will be devices of varied types, different types of devices, different capabilities. As I will talk about further in detail, that there will be a multi-dimensional support, like the support for the normal terrestrial network, along with the devices over the space, devices under the sea. So there will be different types of devices in the network which have different complexities. To handle such complexity, we need a new generation. So the key technologies that will be involved in 6G networks are blockchain, visible light communication, terahertz communication, edge computing. So these are some of the technologies. Obviously, there are a number of research papers. Each are proposing different enabling technologies, such as people are talking about energy harvesting techniques, and different other technologies that people are talking about, but I'm restricting myself to some of these technologies. So, what is the vision of 6G? 6G will connect everything, provide multi dimensional wireless coverage. As I have already talked about, that we will have, besides the terrestrial network that is connecting the devices over uh, the earth, we will have the communication devices over the space, over the air, and under the sea. All of them will be connected together. So, different functions such as sensing, communication, computing, caching, control. positioning, radar. So it will be a holistic solution that will combine all the possibilities of providing a true artificially intelligent ecosystem that can be used to not only provide different network management services, but as well as different applications at the top of the protocol stack. So, multidimensional coverage means that it will not be limited to the terrestrial network, but we will have the satellite connectivity, unmanned aerial vehicle communication network. Uh, Thus, we will have a space, air, ground, sea integrated communication network. So, it will be a holistic solution in which all the different worlds, such as space, satellite, the terrestrial network, and the sea based networks will be connected as shown here. So we have the space, then the space we have the satellites and the other heavenly bodies there. Then we have the air, where we have the aeroplanes, hot air balloons, airships, etc., unmanned aerial vehicles. And at the ground, we have the terrestrial network, and then uh, at the sea, we have other sea-based network. So, uh, different types of applications are possible, such as telemedicine, health monitoring, ultra dense network. Then we have device to device communication, in which devices will be connected together to provide services, vehicle to vehicle communication, augmented reality, virtual reality, extended reality. So, what are the properties of 6G networks? Data rate will be greater than 1 terabits per second. Then the capacity, the bandwidth, it will be around 100 terabits per second. Communication delay should be less than 1 millisecond. Positioning accuracy, mobility support, spectrum efficiency. These are some of the properties of 6G network. So 6G will employ novel communication mechanisms, such as they will use the terahertz communication besides the conventional millimeter wave communication at giga sub 6 gigahertz communication. The band below the 6 gigahertz were initially proposed for usage in 5G networks. It can be employed, then millimeter wave communication can be employed, and then terahertz communication in the range from zero point 0.1 to 30 terahertz can be employed. Obviously, there are certain issues such as molecular absorption issue, such as uh, that it is faded earlier when it is transmitted. So there are issues that people are working on, but I hope that the terahertz communication will be possible in future. Then optical frequency, that is visible light communication, is also possible. Then there will be a number of smart applications that will be possible by use of 6G networks, such as smart city, smart health, smart education. Obviously, people have started talking about in the 5G networks as well, but some of these solutions were not completely deployed in the earlier generation. So 6G is going to complete that task and will deploy different smart cities, smart health, smart education. Then network security is a problem that has to be addressed in 6G networks. So smart city means a city where we have the ICT technologies employed to provide education, health services, shopping services, traffic solution. All of them will be provided in a smart manner by employing ICT technologies based on artificial intelligence, communication networking. to provide a viable solution to general public. So 6G, as I told earlier, that it will provide a data rate of up to 1 terabits per second, very high energy efficiency, and it is also envisioned that it will provide battery-free IoT devices, then very low latency, even less than 1 millisecond, and to end the latency such that applications like remote surgery will be possible. Then very broad frequency band in the range of 73 gigahertz to 140 gigahertz or 1 terahertz to 3 terahertz. Then ubiquitous connectivity, in which ubiquitous computing was an idea that was presented 20 years earlier by Mark Weiser, in which he proposed that we will see a generation that everything around us will be connected over the internet, and we will be interacting with those devices seamlessly without even having the feel that some communication or computing device is around us. So it is woven into our daily lives. So that is the concept of ubiquitous computing, and then connected intelligence with machine learning capability. So what are the use cases of 6G networks? According to different research papers, the possible use cases of 6G will be augmented and virtual reality, the extended reality concept, the holographic telepresence. By use of the holography, we will have the 3D perception of the person available remotely. Then e-health services is possible. Even smart applications will be possible. Pervasive connectivity based on ubiquitous computing will be possible. Industry 4.0, in which the whole industry will be automated by employing robotics, by employing artificial intelligence, by employing automation. The whole industry will be automated, will be working without the support of any human being. So, what are the recent developments regarding 6G? People have started working, although it is a new concept, it is under the conception phase. Uh, for example, in 2020, the Nanyang Tech University, Singapore, and Osaka University in Japan, they have experimented and created a chip for terahertz waves. So terahertz communication, in order to realize that they have experimented similarly in the China 206.25, around 200 gigabits per second data rate has been achieved in the lab environment. So that is a very big achievement, and we are near to achieving terahertz, uh, terabits per second data rate in the future. Similarly, China has launched an experimental satellite into the orbit, and that is also for testing the 6G technology. So they have connected the satellite over the 6G technology in 2020. So the role of AI, what is the role of AI here? In the earlier generations, that is 5G, we have the concept of SDN and network function virtualization. But this softwareization is not going to be sufficient for 6G. We need something smart, something based on artificial intelligence. So the concept that has emerged is intelligentization, that will use communication, caching, and even wireless power transfer. So what is software defined networks? Software defined networks is a concept in which we have very primitive, very naive computing devices. For example, the router, the switches will be very naive, and they are controlled by a control plane in which programming is provided at the control layer. We will have it is programmed and it is controlling the naive devices. So all the intelligence is provided at the control layer. At the application layer, different types of applications are written, and that will instruct the control layer, and the control layer will be interacting with the infrastructure layer. So the at the lower layer we have very naive devices, very naive switches that does not have any intelligence. At the control layer, there will be the control logic that will be used to uh, control or give instruction to the infrastructure layer. So that is the concept of software defined networks. Then edge computing, that is used in 5G, and obviously it is going to be used in 6G as well. So we have different devices that will be connected to the edge, and at the edge we have different nodes that will be connected together to provide uh, a distributed computing infrastructure. So the node at the edge can be used for a number of applications, such as related to artificial intelligence. And then we have the centralized cloud. Then another important concept in 6G network is intelligent radios, the cognitive radios. So you will have a number of spectrum available in your vicinity that is sometimes underused, that is not being used by the primary user. So what you can do is that you can utilize, if you are a community, for example, a computing device would like it to connect to the internet but does not have the requisite spectrum, then it can do a scan of the available spectrum, available channel in the vicinity that is owned by some other person. So it is possible that the other person, the primary user, is not using that particular spectrum, and so you can use that spectrum in the meantime while it is not being used by the primary user. So that is the concept of cognitive radios, and it will be enhanced further by using the artificial intelligence uh, to uh, perform different decisions, such as which particular spectrum is going to be used based on its possible usage frequency, usage patterns in the future. So if the AI predicts that a particular spectrum is not going to be used in the future for a long time, then the secondary user can opt for that particular spectrum. And similarly, AI technologies can be used for spectrum characteristic determination and using machine learning to predict the status of a spectrum in the near future. So using the cognitive radios in different types of decisions, such as spectrum sharing, spectrum sensing, spectrum decision, that is to use a particular spectrum with other users, and to minimize the collision, to minimize the conflict. For example, a particular secondary user is using a spectrum, and at the same time, a primary user wants to use or to get his spectrum back, then there is a conflict. So, to minimize such sort of conflict, the artificial intelligence can be used. Then at the edge, we have a huge distributed computing uh, machinery available that can be used for performing a number of tasks, such as machine learning can be used, dimensionality reduction can be performed to minimize uh, the amount of the data to be transferred over the network. Obviously, Using machine learning based dimensionality reduction techniques, we can reduce the dimension of the data, and that reduced data can be transmitted over the network. Then data analytics can be used, for example, to perform better network management, better network operations. For example, we can understand the essential characteristics of the wireless network, the behavior of the network, and perform different types of operations such as intelligent resource management, protocol adaptation, network slicing, cloud computing, signal processing. All of these things can be performed in an intelligent manner, have we the desired amount of the data available. For example, let's suppose you have an unmanned aerial vehicle traveling over the air, and you have to determine the its channel path loss model. So you can model the path loss model based on artificial intelligence. You can predict the mobility of the device, and predict the device behavior in the ground network as well. So mobility management can be easily achieved based on artificial intelligence. You can determine that a particular unmanned aerial vehicle is going to follow which mobility pattern, and then based on that, different problems such as path loss model can be determined, such as multipath filling effects can be handled based on artificial intelligence. Then obviously I have discussed that different types of smart applications are possible using 6G networks. Using the big data analytics, we can perform four types of analytics. Descriptive analytics can be used to gather better information about the network, the traffic profile, channel conditions, and so on. Then diagnostic analytics can be used to determine what is the possible cause of a fault in the network, why a particular fault has occurred in the network, identify the root cause, the particular anomaly that is causing the malfunction in the network, and then based on that we can improve the network reliability and security. So descriptive analytics is to use to gather the data about the network to understand the behavior of the network. Diagnostic analytics can be used to detect fault, to trace fault. Predictive analytics can be used to predict possible future events that might occur in the future. You can anticipate them in advance and can take corrective actions. And finally, prescriptive analytics can be used to suggest alternatives, the options to resolve those anticipated future scenarios. So based on predictive analytics, you get to know that there might be certain issues in the future. Then you can use the prescriptive analytics to determine its solution. Similarly, the mobility and handover mechanism can be handled very easily if you determine the mobility scenario of a particular moving device, and then you can devise a mechanism for intelligent handover. However, it is worth noting that using such a large volume of the data, everything is analyzed, everything is recorded, uh, the provenance data is recorded. For example, for modeling a blockchain in the 5G or the 6G network, uh, there might be issues about data security, privacy, ethics, and ownership. So we need some policy handle the data privacy issue, data integrity issue. The laws and regulations must be developed to address data ethics and the ownership issues in the context of 6G. So there must be a proper balance between risk and benefit. Then 6G network is going to use different novel spectrum such as visible light communication is possible. The terahertz communication is possible. We have already talked about it, the terahertz communication. There are certain issues with terahertz band, such as propagation loss issue, molecular absorption issue. They are absorbed in the air, high penetration loss, and there are problems in designing antennas for transmitting the terahertz band. Some of these solutions can be addressed. For example, the propagation loss can be compensated using directional antennas. By using directional antennas, we can transmit the data to a larger distance. So the focus beam can be transmitted to a larger distance. And similarly, there are certain terahertz bands that are not affected severely by molecular absorption, so we can transmit into that band. Then finally, edge computing is going to be a very important feature of 6G networks, in which the uh, we are anticipating an AI empowered edge computing environment. And then there are problems, or you can say opportunities, such as using the caching to handle the to provide the large bandwidth, to provide large data rate, because if something can be cached at the edge, then we can avoid the network congestion, we can support a large number of devices. So the final part of my presentation is a novel technique for caching at the edge. Uh, Basically, it is a solution for edge computing environment, irrespective of whether it is a 5G network or a 6G network. We earlier presented it for a 5G network. The same can be used over the 6G network. Why caching at the edge? Most of the requests on a mobile or a cellular network are for videos or social media content. So what people are doing over the social media, primarily they are browsing, they are using the content that is repeated, that the same content is repeated for multiple users. So if we can cache the videos that is very popular, uh, then we can gain significant performance improvement. So the objective is to cache at the edge on the small base station or mobile terminal. So we have the rise in the demand of the data. So how to cope with these soaring demands? Obviously, one way is to increase the capacity to have more access points of base stations. Uh, but there is a limit to the network densification. We cannot have a large number of base stations installed. So obviously, there must be some novel mechanism. So in some of the researches, caching has been termed as a disruptive technology. It has totally changed the paradigm. So if popular contents can be proactively cached at the edges closer to the network, we can avoid the load at the backhaul network. The core of the network can be we can avoid the congestion at the core of the network if we cache the popular content at the edge. So the request will not be required to travel over the network. So that is the concept. There are a number of caching solutions proposed in the literature. For example, machine learning has been used, uh, transfer learning has been used, and there are multicasting based solutions. There is a solution based on operation research optimization, stochastic solutions, cloud based solutions. So all of these are available in literature. What we are going to do is that we are using a machine learning based solution that is based on collaborative filtering. Collaborative filtering is a recommendation based solution The objective is that people who like similar thing in the past would like to have similar opinion in the future as well. So if a two-person like the same thing, for example, if two-person like the same thing, then if we don't know if a particular thing is liked by a person, we can go for the like-minded person. We can see if the like-minded person also likes that thing, then it is also possible that that person is going to like it as well. So based on like-minded people, we group them, and based on their choices, we can anticipate about a new item, a new person. So that is the concept of collaborative filtering. And there are two primarily approaches: neighbor-based approaches and latent factor approaches. So neighbor-based approaches is based on a set of neighbor to a user or item. In the latent factor approach, we perform the matrix factorization. So we have a popularity matrix we factorize into two uh, sub matrix based on matrix factorization based on machine learning, and then latent features are calculated. So this idea was initially proposed in one of the research paper in which a popularity matrix is calculated by solving a least square problem using the singular value decomposition technique. So this is very popular technique that is used in recommendation based systems. What we do is that we have a popularity matrix. We first decompose into two sub matrix based on singular value decomposition, and then they are multiplied further to get a low dimensional representation, to get another popularity matrix with reduced latent features. So that is the concept. So we have this popularity matrix, and we decompose it into two sub matrices: user and item based matrix. But there is a problem. Uh, Most of these solutions in the literature does not consider the context into account. Uh, For example, we would like to consider the location of a person while caching an item. We would like to understand the mood of the person. What is the mood of the person? If he is happy, if he is angry, we need to consider the particular context uh, before performing the caching. So, in the established domain of collaborative filtering, collaborative filtering is a very novel approach that has been used in machine learning for the past few years. We have the concept of context aware recommendation system, but it has not been applied to caching at the edge. So the concept is there, but it has not been applied into the domain. So our idea is that employing these techniques to the research earlier proposed by Bastet. So what we want is that the demand for data items can be predicted based on a popularity matrix. What we will do is that each small cell base station is equipped with storage capability to cache the popular content. So at every base station, we have some capacity to store the popular content. And from the literature, it has been found that the request for the items are basically you can model them using a zip f distribution. So what we have done is that we have extended the popularity matrix to three dimensions. So we have the users, items, and context. Based on them, we have the rating. And this popularity matrix can be factorized using the solutions already available in the literature. So what are the contextual information that we should hold? There are six contextual information, the information about the user, the social information, the user's task that he is performing, location, infrastructure, and physical condition. So these six attributes are used to predict the likelihood of an item to be cached at a base station. So the contextual information can be acquired from different sensors such as uh, we can have a proximity sensor, we can have the temperature sensor, we can have the location sensor. So all of these information can be used as a context. So the popularity matrix is indexed based on three things: the particular user who is making the request, the item which is being requested. The item means here the video item being requested, and the specific context in which a video or a data item is requested. So here we are dependent upon not only the user, not only the item, but also the context in which a video item is being requested. So the large popularity matrix is first converted or broken down, factorized into three submetrics, that is the user, the item, and the context. And then a low rank version is constructed again using uh, gradient descent algorithm. Machine learning has been used to construct a low ranked matrix that is normally done in recommendation system. So we have employed the same technique here. So a large uh, popularity matrix is first converted into three submetrics, and this is the singular matrix, the diagonal matrix that is also generated as a byproduct, and then they are used again to construct a low ranked version of this popularity matrix in which we have the information about the missing items as well. So based on gradient descent optimization and using this formula, the loss function, we can perform or we can generate a low ranked version, and then they can be used for recommending the particular item to be cached. So how do we perform caching? The resultant popularity matrix can be used for deciding the items to be cached proactively. So here we are performing the caching proactively. We are anticipating that if a particular item is going to be used in the future, so we can probably cache it such that in the future the same request is not generated. So greedy caching is performed if we found that if an item is going to be used in the future, we can cache it greedily, and this can help in offloading the network. We don't have to generate the network traffic to put the load on the net backhaul of the network. We don't require to regenerate the traffic. So that is the concept. So concluding my presentation, this was an idea that we presented, and we are working on it to get the experimental results. So in this presentation, we have talked about 6G network. AI is going to play a very important role in 6G network, and 6G networks is based on a number of enabling technologies such as blockchain, artificial intelligence, mobile edge computing, and the use of the novel communication spectrum, novel modulation techniques, intelligent radio. Finally, in this presentation, context-aware caching scheme has been presented. So right now we have done some of the projects in the past. For example, Aladdin is a data management framework that we worked on in our PhD project. A tool for ontology development and editing has been worked on. And recently, I have done my postdoc on load balancing in cloud edge computing. So this was the presentation. If we have time, then I would like to show one of the videos. So can you tell me if we have time or we can take the questions?
I think we have about 7 minutes left.
Okay.
So this video, I think, is how much lengthy is this video is. So,
3 to 4 minutes video, but we can have the questions. I think there are 2 to 3 questions I can see in the chat window. Let me check.
no, I think that's not question from attendees. I send you some messages. So, okay, so I think we can ask for questions. If all the attendees, if you have any questions, you can uh, ask the questions on chat or in Q&A section, or raise your hand. So I will allow you to talk, and then you can basically talk here. So I think so far I didn't find any questions. So while if you think of, so they are thinking for any questions, so I think you can play the video quickly. So 3 minutes, and then we'll finish the webinar. So it doesn't, the voice is not there.
Why is it? Can you hear me? Can you hear the video?
Yes, your voice is there. You need to, I think, share the system voice as well. Check. Yes, Dr. Noman, actually the voice is not coming up for this video.
Okay. So voice is not coming. So what can we do? How can?
I think there's an option at your end. You need to share the system voice as well while sharing the screen.
Can you hear now?
No.
So I don't know where is the option. What should we do? Hello.
Yes, I think that it's not shown here to me as well. So, okay, so I think what we can do, we can share the link of this video. You can just
Yes, I
share
will
in
share the
chat.
presentation with you. I will
Yes.
share the presentation with you,
Okay.
in which we have the video link, so
Okay.
people can watch it.
Okay. That's fine. So, okay, so I think we don't have any questions. Anyone? Okay, so as I don't see any questions, so I just need to wrap it up. So thank you very much, Dr. Noman, for your great presentation
Thank you very much
on
for
CG
inviting.
networks. Okay, so it's very informative, inshallah, and we will be looking after for future presentation, inshallah, from you. Okay. So
Inshallah.
thanks a lot.
Thank you very much.